Assalamu alaikum everyone, and today we are going to talk about higher degree polynomial. So we know how to graph quadratic equations, which is like the equations that are second degree polynomials, but there are still more higher degree polynomials like cubic functions and quartic functions, and these can be tough and can be, take so much time to just calculate all of them. But there are some useful tricks to calculate these functions. We also want to know what happens to the end behavior of the function, which is what it does as x turns to positive or negative infinity. Now, this concept is pretty important because we're exactly telling what the graph will look like here. Now we're going to learn about leading coefficients. Now this is a technique we can use to sketch graphs. Let me show you an example. So let's say we're going to graph a function that is y equals to x cubed plus 3x squared minus 6x minus 8. Here we have the leading coefficient, meaning the first, term here has a coefficient of 1 and an exponent of 3. Now the coefficient is odd, okay? So the coefficient is odd. The exponent is odd and the coefficient is positive. So it will, on the left side, this is the left side here, it's going to drop down towards negative infinity. And on the right side, it'll rise up to positive infinity. This goes for things like when there is an even exponent with positive coefficients. Everything goes up when it's even, but it's negative. Everything goes down. This goes for both quadratic and higher degree polynomials, by the way. And if it's odd and it's positive, then the right goes up and the left goes down. And if it's odd and negative, the left goes up and the right goes down. Remember that it's a little confusing. Now we still haven't have enough information to do a complete sketch. We just know the side to side. Now we need to know what happens in the middle. So we need to find 0, which graphically speaking, we can say the x-intercept. Let me just draw the coordinates. Now we have to get back to the solving quadratics, but except this equation would look a lot different. Let's just say that. A lot different. And we need to set our polynomial to 0. And for solving for x, what we need to do is we need to, factor or do synthetic division. Now, I'm not going to do all the work out here, so basically by doing synthetic division here, let's give another example. I don't want to start with this example. Okay, so everything is basically the same because the leading coefficient is the same. Actually, let me make it darker so that it's easier for you guys to see. Much better, at least. Here, by doing synthetic division, we get x plus 3 times x plus 1 times x minus 1 equals to 0. So so the zeros are going to be x equals to 3, x equals to 1, and x equals to negative 1. These are what we are going to write in our sketch graph. So let me just draw those random points. Make it as accurate and nearly as possible. Here it looks exactly like this. So now that we know what happens in the middle and what happens outside, now we can sketch. So on the left side, which is here, it drops down. So we just draw a line here. Then it curves up to 1, so negative 1 to 1. And then it drops down again up to 3 and then goes up. So we have a complete sketch. Now these aren't gonna give us the maximum and minima. We'll need to learn calculus for that, and we still have a lot of algebra and trigonometry even to cover before we touch calculus. So keep that in mind, but this is a rough approximation. Enough in some calculations. There's one last thing I'd like to show, but I'll give an example. So let's say another is negative x to the 4th plus, 4x cubed minus 4x squared equals to 0. So doing synthetic division, it's negative x squared times the group x squared minus 4x plus 4 equals to 0. Then by doing a few maths, we can get this, and you see one of the zeros is twice. This will be important. And here on the outside, we can change it to negative x and x. So we can see one of the zeros is 0 itself. And we can also see that this is that the negative 2 is twice. So these are the things, and by doing the graph, we can see it goes something like this. That it touches the 2 and it doesn't just turn back again. And remember that this is an even exponent, so it goes down. And with that, we've understood everything that we need to in higher degree polynomials, but we need to practice for more of these. Now, before we move on to our next video, remember to subscribe if you want more of these math and science tutorials. And thank you for watching, and I will see you next time.